The next topic is CDMA. Third point is CDMA. CDMA stands for Code Division Multiple Access. It is also called as the spread spectrum and code division multiplexing, one of the computing transmission technology for digital mobile phones. The transmitted mix the packet constituting a message into the digital signal stream in order determined by the pseudo random number, that means PRN sequence, that is also known as the intended receiver, which uses it to extract those part of the signal intended for itself. Hence, each different random sequence correspond to a separate communication channel. Here the unlike TDMA, in CDMA all stations can transmit data simultaneously. There is no time sharing. Then CDMA allows each station to transmit over the entire frequency spectrum all the time, and multiple simultaneous transmissions are separated using coding theory. In CDMA, each user is given a unique code sequence. And the first is analogy. CDMA means communicating with different codes. For example, consider a large hall with many people, and some of them understand only English, some Hindi, and some Chinese, etc. Then these people communicate with language and which they understood. The common channel, that means hall, allows communication between several people but in different language codes, that means analogy. Then second is the idea. Here the some basic idea of CSMA is explained as follows. Here let us assume that we have 4 stations 1 2 3 4 that are connected to the same channel, and the data frame station 1 are D1 and stations D2 are D2 and so on. The code assigned to the first stations is C1 and C2 and so on. The assigned codes have two properties. First one is the if we multiply each code by another, then we get 0. And second is the if we multiply each code by itself, we get 4 number of stations. When these 4 stations are sending data on the same channel, then station A multiply its data by its code, that means D1 dot C1 here. Then stations B multiply its data by its code, that means D2 dot C2. Then and so on. The data here also D3 dot C3 and D4 dot C4. The data that go on the channel, sum of all these terms as shown in this figure. Here the D1 dot C1 is plus D2 dot C2 plus D3 dot C3 plus D4 dot C4. Any stations that want to receive data from one of the other 3 stations multiplies the data on channel by the code of the sender. Then next is the chips. Here the code assigned to each station is a sequence of number is called as the chips, and this chip are called as the orthogonal sequences. These sequences has following properties. These are the first. Each sequence is made of n elements, and where n is the number of stations as shown in this figure. First see the first. Then C2, if you multiply the sequence number, the every elements in the sequence is multiplied. Then here the multiply sequence is multiplied by that element, and this is called as the multiplication of the sequence by scalar. And here also for example, plus 1 minus 1 minus 1 minus 1 into here the 2. here the is equal to +2 +2 -2 -2. If we multiply two equals sequences, the element by element, and add the result, we get n, where n is the number of element in each sequence. This is called as the inner product of the two equal sequences. And here also one of the example is the +1 +1 -1 -1, then dot into +1 +1 -1 -1 is equal to 1 + 1 + 1 + 1, that means 4. If we multiply two different sequence element by element, add result, we get 0. This is called as the inner product of two different sequences. For example, +1 +1 -1 -1 into +1 +1 +1 +1, that means +1 +1 -1, that is 0. Then adding two sequences means adding corresponding elements. The result is another sequence, and here one of the examples, and +2 +2 0 0. Then data representations, encoding and decoding. The data representations and encoding is done by different stations in the following manner. First one is the if A stations need to send a 0 bit, it encodes it as -1. Then if it is need to send 1 bit, it encodes as +1. And when stations as ideal, it send no signal, which is interpreted as a 0, that means silence. For example, if stations A then sending stations 1 and stations 2 are sending 0 bit, then stations 3 is silent and stations 4 is sending 1 bit, then data at sender side are represented as -1 -1 0 and +1. Each station multiplies the corresponding number by its chip, and which is unique for each station. Each station sent by this sequence to the channel, and the sequence of channel is the sum of all four sequences as shown in this figure. See, this is the figure, and figure having the four stations. Here the station 1, 2, 3 and 4. Here the stations 1 having the sender data is -1 -1. Here this is the silent. We have already seen the stations 3 is silent, that's why here the 0, and the stations 4 is sending 1 bit, here the 1 bit. Then these stations having the datas, here the data is also we have already provided. Here the C1, then C2, C3, and here the C4 data. Then here the C1 D1 dot C1, and the data D2 dot C2, and the D3 dot C3, and the D4 dot C4. And this is the common channel, and the common channels calculating the data, just adding all the elements, corresponding element. That means here the first element is -1, then add this is +1, then add this is the 0, and then here the first bit is +1, then -1 plus -1, here the -2 plus 0 plus 1, that means -1, that's why here one first is -1. And calculate these four datas. Here the second time -1, then -3 and +1, this is the data. But if the station 3 multiplies the total data on the channel by the chip code of the stations 2, then how to calculate? Here this is the formula. Here the data calculations by using just addition. Add for this data plus here the stations here we have already provided this data, and additions is suppose here the -4, and divide this result by the total stations, and we have total stations number of 4 stations, so divide by 4. -4 divided by 4 is equal to -1, and -1 is corresponds to the here -1 is correspond to the data bit 0. That's why here the -1 corresponds 0 bit, hence stations 2 send 0 bit, which is read by stations 3 in this way. Next is signal level. Here the figure shows the corresponding signal for each stations using NRZL and the signal that is common, that is on the common channel. See, this is the bit 0 A, that means the first, and here the -1, -1, -1 and -1. This data from the here, this is the, see this figure here, this data how to calculate. Here -1 is multiplied by this data, that's why here the -1 is multiplied by this one, this one, this one, this one, so that's why all is -1. Here this -1 is multiplied by this data, here the 0 multiplied by this data, that's why all 0, and here the +1 is multiplied by here this data, here the provided this data, that's why here calculating, and here this data bit 0, -1, -1, and it represented by graphically, here the positive side and here the negative side, here the all are minus, that's why this is the minus, minus, -1. Then second data bit 0 at the second level, that means second B, here the second means B, data is -1 +1 -1 +1, here the -1 +1 -1 +1. Then second third is here the C, C means here the all are the 0, that's why here the 0, and last is D, that means fourth section, and here the +1 -1 -1 +1, here the +1 -1 -1 and +1. Then data on channel, and data on channel, that means this data, that means the additions of all this channel, and the addition of channel is here the -1, this first one is the -1, then here the -1, then -3 and +1, and represent by using this graphically, here the -1 -1, this is -3, and this is the +1, this is the signal label. Then his figure shows the stations 3 can detect the data sent by stations 2 by using the code for station 2. Here the data on channel, we have already known the data, -1 -1 -3 and +1. Here this is the representations, -1 -1 -3 and +1. This is the data on channel. Here the stations 2 code is that means 3 is +1 -1 +1 -1, this is the +1 -1 +1 -1, and here the inner product result, here this is the inner product result, here see this product, and this product result is +1, here -1 +1 -3 -1, so it is represented by graphically, here the -1, then he +1, then he -3, and this is the -1, and here the summing of the values, and summing of the values is -4, and it is represented as the, this is the -4, and next is this -4 is divided the result by total stations, so -4 is divided by +4 and is -1, and it is -4 is corresponding to the 0 bits, that's why this is the 0 bits, hence stations 2 send the 0 bit, which is read by the stations 3 in this way. Then last topic is sequence generations. Then we have already seen in this diagram, here these are the sequences, and these sequences, how to calculate these sequences. Here in the last topics we have seen how to generate these sequences. Here to generate the chip sequences we use a alls table, which is a two-dimensional table and with the equal number of rows and columns as shown in this figure. Suppose first one is the W1. Now here the alls tables, that's why W1 is equal to +1. only this information is given. And second rule is w2n is equal to here the matrix wn, then wn, and here this is the complement of wn. And these are the two rules. First rule is w1 is equal to plus 1, and second rule is the matrix of w2n is 2 by 2 matrix, and here the wn, and in this place is the complement of wn. Then how to calculate this sequence generations? Here first is w1 is equal to plus 1, then put here this is the w2, w2 here the put here w2, that means here put first one is the w1, wn means here the n means 1, that's why here put this w1, then here w1, and here w1 value is plus 1, that's why here putted plus 1 and plus 1. Then here this is the complement of wn, that means plus 1's complement is minus 1, that's why here putted minus 1. So here we have two generated two matrix w1 and w2. Here we get the two tables plus 1, and here w2 is plus 1 and here is minus 1. Now we calculate the w4, and w4 here the w4 means here the here w2, then w2, here w2, and here the one complement for w2, here the w2 means plus 1 minus 1, these sections w2, then here w2, and here w2 just putted. But here the w here the complement, here the this is the complement putted, and the complements means exactly opposite, here the plus 1 means here minus 1, then my plus 1 minus 1, then here the plus 1 means here minus 1 its complement, and here the minus 1's complement is plus 1, that's why this generated for w1, w2, and w4. This is the generation for here general rule and example for creating Walsh table. And in the Walsh table each row is a sequence of the chip, and here consider this is the row, here the first row, here the second row, here the third row, and there the fourth row, and we can choose the minus 1 or plus 1 for the chip for the trivial table, and we choose plus 1 according to Walsh. If we know the table for n sequence, wn we can created, and that's why here the sequence table is generated plus 1 plus 1 this, and second one is plus 1 minus 1 plus 1 minus 1, here the plus 1 minus 1, and last is plus 1 minus 1 plus 1, and therefore this is the chip sequences we have already used in this diagram, and this is the chip sequences. Here the plus 1 then minus plus 1 minus 1 plus 1 minus 1, then here the plus 1 minus 1, and last one is the plus 1 minus 1 and plus 1. These are the sequences generations by using this table. And here the last chapter is the medium access sublyer is over, and our syllabus for first sem computer network first syllabus is also finished.